So domain is restricted for sign on the unit circle between pi over 2. Where is negative pi over 2? Right across, right? So it's restricted from there to there. I want to erase those. So if we're going this way, we have to count negative, right? So what is 11 pi over 6 negative-wise? Oh, that's weird. It's doing that. Negative pi over 6. What's 7 pi over 4? What's wigging out? And then negative pi, or 5 pi over 3 is negative what? So you remember the little trick. You can just take pi over 3 and you go straight down, and that's negative pi over 3. You take pi over 6, you go straight down, that's negative pi over 6. So we're going to get answers where you have to say negative. We can't say 11 pi over 6 because that's not within the domain, because the domain goes from positive pi over 2 to negative pi over 2. Okay? So you want to look at that unit circle. We're going to, it gives you the domain right here, right? So you're going to write that domain below here. So negative pi over 2. Negative pi over 2 less than or equal to x less than or equal to pi over 2. And then if we're doing a sine graph, right, because our amplitude on this function right here is 1, then the range is going to go from negative 1 to positive 1, right? Because it's got that nice little wavy curve deal. So negative 1 less than or equal to y less than or equal to 1. Okay, and then all we have to do here is flip x and y, right? When we do domain and range, less than or equal to x, less than or equal to 1. Take care of the easy stuff first. So it's still, like, you just have to find the values and think about it, and you're just switching x and y. So once you understand it, it's not that hard, but when you first learn it, it's confusing, but you'll get it. So if I'm looking over here and I have lowest, right, I want to see what my y value is going to be at negative pi over 2. So I'm going to write some ordered pairs over here. I find it the easiest way to understand, right? And then we're going to switch the order pair for the inverse, right? Because that's how we do inverse, switch x and y. So if you look at negative pi over 2, is sine, first of all, x or y? Y. Where do you look on this unit circle I gave you? Bottom right. You look sine theta, and it says equals y in gold. Okay? If we're doing cosine, what is it? And if we do tan, it's y over x. Okay? So keep that in your head because it makes it much, much easier. So what is the y value at negative pi over 2? Negative 1. 0, 0 is the easy point. So we can flip it on the right side here for inverse sine. So arc sine and inverse sine mean the exact same thing. Okay? They'll write it both ways, so you just got to deal with it. So we're switching them. Okay? 0, 0, and then if I do pi over 2, what's the y value? 1. And then we're going to write the order pairs over here, switching x and y. 0, 0 obviously stays the same, and 1 pi over 2. So if we graph that, we have negative pi over 2, negative 1. We have 0, 0, and at pi over 2, it's 1. So we're just graphing part, right? We're not doing a whole period of it. We're just graphing part of a period. So this part of the period kind of curves up like that. That was kind of weak. Curves up like that. And this one curves down like that. And then the curves flip when it's inverse, right? So we're going to graph the order pairs first. So at negative 1, and realize x and y switch. The axes switch. So that's another confusing thing, right? Because you're not used to seeing that kind of thing. So at negative 1, it's negative pi over 2. So the points kind of end up in the same relative spot because we switch the x and y axis. But your curves, instead of it going kind of down, it goes up to here. And then this one goes down like that. So the curves kind of flop. flip-flop. Let me get my notes up. Can do it. There we go. Okay. So, next one. Cosine. Cosine is what? X. Okay. So we're going to do same thing. Cosine domain goes from 0 to pi. So 0 to pi. So which quadrants is 0 to pi? Q1 and Q what? Q2. Which quadrants are, if we talk about sine, what quadrants are we talking about? Quadrant 1 again. 4. Good. So the only reason I write that is sometimes it's easier to think about it with quadrants. Sometimes it's easier to think about it like where pi over 2 and negative pi over 2 are. And whatever way works best for you, I don't really care, right? But I just give you options of how to memorize this stuff because you have to memorize these domain restrictions in the unit circle of negative pi over 2 less than or equal to pi over 2 and for cosine 0 to pi, right? And then same thing here. It goes from negative 1 to positive 1. If you put in like cosine of negative 2 in your calculator, you get an error message. Okay? And then we switch over here with x in the middle. So if we plug in 0, what is the x value at 0? 1. And if you think about that cosine graph, right, it always starts high, middle, low. So we're following that same pattern here. We're just doing part of the period. If we plug in pi over 2, so at pi over 2, what is the x value? 0. Right? So you're looking on top of your unit circle, finding the x value. It's in gold. And then if we do pi, what is the x value at pi? X value at pi is negative 1. Right? So we're going like this way. I want to make it thicker though. And then it kind of bows down a little bit, right? So then we flip it on the other side here. So 1 comma 0, 0 comma pi over 2, and pi comma negative 1. So 1 comma 0 right here.
The last one's wrong. You didn't flip it.
I did that last period too. Thank you. So we got to flip it. My bad. So negative 1 comma pi. So we have 1 comma 0. So put a dot right here. Then we have 0 pi over 2 right here. Right, so we're getting, and then at negative 1, it's pi. So it's going to curve kind of the opposite direction, like that. Okay, we good? So tangent, look at that domain. What's the difference between the domain on tan and the domain on sine? It's not equal to, right? So because they're asymptotes at tan, right? If we have 1 divided by 0, you can't divide by 0. That's why it's undefined, and that's what creates that asymptote. So you can draw those in at negative pi over 2 and positive pi over 2. Right? And then on the inverse one, they go horizontal as opposed to vertical. So we can write that domain as well. So we go from pi over 2 less than x, less than, or negative pi over 2, sorry, and then pi over 2 at the end. And then it goes from, what is the range for tangent?
All of them.
All reals. If we write that in interval notation, you write from negative infinity to positive infinity. Right? Remember interval notation from algebra 2? It was a while ago. So if we, 0, 0 is the easy point. Right? Because if we do tangent, if we do y over x at 0, 0 divided by 1 is 0. So we have a point at 0, 0. Where else do we have a value for tan that we can graph on this little coordinate plane? Pi over 4. Good. So when x is pi over 4, y is what? 1. When x is negative pi over 4, y is negative 1. Okay, so 1 pi over 4, 1 right here. Pi over 4, negative 1. Remember, your tangent graph kind of goes down like that, goes up, using those asymptotes, like that. So then we flip x and y, so 1 comma pi over 4, 0 comma 0, and negative 1, negative pi over 4. So 1 pi over 4, 0, and negative 1, negative pi over 4. So goes like that and like that. So here, domain is going to be all real numbers, negative infinity to positive infinity. And the range is going to go from negative pi over 2, less than y, less than positive pi over 2. When you write those in-between inequalities, so it's always less than or equal to, depending, sine, cosine, tan. So where's tan okay? What quadrants? Q1 and from negative pi over 2, or positive to negative pi over 2. Q4, right? Negative, because you got to count negative down to the bottom. So you can always do that trick, right? The easiest trick ever. When you go, you want to know pi over 2 right here. If you want negative pi over 2, you just go straight down. If we have pi over 6 here and we want negative pi over 6, you just go straight down. So that's how you can figure out where the negatives are. You can always just count them out, right? That'd be negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2, etc. Okay? So tangent and sine are okay in Q1 and 4. Cosine is okay in Q1 and 2. So they'll give you values and you'll find values when we're doing the inverse, and your answer will be 11 pi over 6. That is not within the domain. So if your answer is 11 pi over 6, what is the actual answer? Negative pi over 6. Okay? So that's like the confusing part of it. So we're going to write the domains over here to help you remember. So we're going to go sine. So we're going to go sine is from negative pi over 2, less than or equal to x, less than or equal to positive pi over 2. And we're talking about domains here. And then cosine goes from 0 to pi. And tan just doesn't have the equal to. Negative pi over 2, less than x, less than positive pi over 2. So remember, arcsine and inverse sine, those mean the same thing, okay? Arcsine, inverse sine, same thing. So if we have if we're thinking sine, look at the number 1 right here. We're thinking sine. Are we thinking x or y? So what is a y value where sine equals 1? Or what is the, I should say, radian value? That's a good thing to write up here too. To help you remember, your answers are in radians, not degrees. Okay, so where is the y value 1 on the unit circle within the domain of sine? Pi over 2. That's your answer. Okay. How about, so you look at the unit circle, we're looking for a y value, we're doing inverse sine. We want to see where the y value is positive root 3 over 2. Raise your hand, don't say it out loud. Look on your unit circle. Elise. Pi over 3. Good. Is there a negative 2 on the unit circle? No, so you write does not exist, DNE. Right, they'll just throw those in there to mess with you. Don't let it, right? There's no negative 2, negative 3, positive 3 on the unit circle, so you don't have to do it. Okay, so where is cosine negative root 2 over 2? So where's x negative root 2 over 2? Three pi over 4. Is that within the domain of cosine? Show enough. All good. Okay, cosine, inverse cosine of 3 does not exist. Okay. All right, where's inverse cosine negative 1? So where is the x value negative 1? At pi. Because it's equal to, that works, right? Because we got the equal to right here in that domain. So where is tan root 3 over 3? So that's negative, right? So positive is at pi over 6. So if we do inverse tan of negative 1, remember tan's in 1 and 4. So it can't be 3 pi over 4. So we look at the unit circle, right? So right here, right here, tan's negative 1. What's the negative value of 7 pi over 4? Negative pi over 4, right? Just straight down. So negative pi over 4 for that one. Right, that is within the domain of tan over here. Does not like when I switch between windows. And then square root of 3. Where's tan square root of 3? Pi over 3. Okay, one more, and then we're good. We're going to do number 11 here. So we're looking at this little picture over here. Which trig function am I going to use? Tan as it relates to theta is what? Opposite, adjacent, or hypotenuse? 10 is what? Because theta's in the corner, so that's opposite, right? And d's adjacent, so we're going to use what? Tan. So we go inverse tan. 10 over d, right? The order is important. And that will give us theta. And then they tell us right down here, d is 75. Couldn't be easier as far as the problem goes, right? So you do inverse tan in your calculator, you hit second tan of 10 divided by 75. When you do that, you get 7.6 degrees. Again, don't forget that degree symbol. Any questions? This class could not be more different from period 1. I'm going to stop the recording.